on you. Programming languages. First time you hear about programming, whether you are a student or you are someone who would like to shift his career from another career to programming or to IT sphere in general, you don't know sometimes what is programming. You don't know what is the roadmap, what is the similarities between programming languages and what is the differences. If there is anything in common between all the programming languages or not. Starting by you looking sometimes into the computer, you search, you Google, and you have a dozen of questions with no answers. You don't know from where to start because really programming sometimes if you are mature you don't know from where to start. It looks like an ocean and someone drop you in the middle of the ocean and asked you to swim to the shore. So you don't know what is the road map in programming. I was in exact situation like you are now. I would like to share with you my experience about the perfect road map to learn programming language and to switch between programming languages if you want in the future. The road map we are going to discuss here, it is the logical road map of what is common between all the programming languages, which makes it easy for you in the future to switch between programming languages after you understand what is common and how each programming language is using this common functionality or common methods or common options to share knowledge and to write code. My name is Ahmed Sami. I'm a software engineer. I will be so glad to share with you my experience and I'm so enthusiastic to share a beneficial knowledge with everyone. Hopefully it's going to add value to your life. Let's get started into programming language. Our agenda is so simple. What is programming? For what we are using programming and what is the common concepts between all programming languages which makes it easy for you to follow, then you can achieve your goal faster than you expect if you don't know the roadmap of programming language. This is the main reason of that application, roadmap of learning programming language. So let's get into what is programming language. Programming language is a communication which means if you would like to do specific task, a specific job, you ask someone a specialist, you explain your idea, you explain your thought, and that specialist guy will do what you're asking for. That's a communication. It's exact same way when you have some kind of application idea, website idea, and you would like to do this on your own. So you learn programming languages as a way of communication with computer to achieve a specific goal and for you to do that goal yourself. After communication is doing tasks, which means doing application, doing website, doing whatever you want to do with this programming language is totally up to you and up to your imagination. Personal development. If you learn programming language but you are not that interested to work as a programmer, at least you will learn the roadmap, you will learn the logical thinking of programming, you will learn the concept of divide and conquer. If you have a bigger problems, how to divide them into smaller problems and start solve them one after another. That's how programming is a logical thought and you turn them into code. After that you have the future investment. Everything is changing rapidly around us. As you can see that nowadays programming, IT sphere, artificial intelligence, machine learning and all this stuff are so fast developing. For that reason, when you invest in your future by learning programming, that something will add value to your life. If you would like to continue in this field or at least if you would like it for a personal development. Moving into the common concepts between all programming languages. First important concept of programming language, regardless which programming language you are using, is memory. Memory is the main and the fundamental block for all the programming language. What is memory? Memory, place where you store something, then later on you retrieve this something. After that you can process some knowledge, some data, whatever the goal you want from this, then you save it and you store it back. So you can consider memory as a box where you put some stuff, and after that you take this stuff from the box, you use them or whatever you are doing with, then you put them back into the box if it is necessary to return them back into the box again. This is the memory where you put everything. For programming languages, we have levels. Language level. What does it mean? First one, we have high level programming language, where you are as a human being are going to write code in English understandable language. You will not write some sophisticated stuff and you don't know what it is, some symbols, characters and numbers and that's it. No, you will write your language or you will write the code in English language. For example, you would like system.out, for example, print, for example, show me something, for example, add something, subtract something. You will write a specific English command and the application itself, it has compiler, converter, interpreter, will take these English phrases and will turn them into low-level language. Low-level language where the computer understands binary code, which consists of 0 and 1. That's computer understand. Computer never understands your English language. For the computer, English language is nothing, or whatever language. Everything in computer is turned into low level 0 and 1 language. But for you as a programmer, you will write very easy and simple phrases in English, and the computer, the application will turn them into the specific low level language to run your command and your application. Moving into the main building block of any programming language, which is variables. Variable is name of reserved location in the memory. As far as you know, memory is where you store your data. To remember each location in the memory, it's so difficult for us. For that reason, that is the address of the memory where you store some data. Because as a human being, it's very difficult to remember this address. We will give this address a name. For example, let's say this address will store street. So we say street name and we give it this address. So the memory storing value into a location. I give this location name because as far as you remember by now that we use high level language, which means I will write in English variable street name equal, I will give it street name, for example, whatever street name. For the variables, we have something we call it data type, because our data is consist of types. For example, you use numbers. Number is data type. You use characters like alphabet. It is character data type. You use phrases. It's called text. You use strings. It consists of characters. True and false. It's Boolean logical operation. Complex object. All these are variables. We have numbers, object, complex things as data type, logical as data type, true or false. Characters, variable should have specific data type stored into the memory. From data type, how can I use this variable? How can I declare this variable to add this data into my memory? We have 3 steps in general. Declaration. We start by declaring variable. How to declare the variable? As you can see, here you have it, data type of the variable, then variable name. That's it. That's called declaration. You didn't give any value yet. And that's how it looks like. Var, name of the variable var1, for example, and you didn't use it yet. How can I assign this variable? How can I give it some value? By moving follow. Here is the data type of the variable. Name of the variable equal, I give it value. Remember with me, of memory. Data type is type of data will be stored in the memory. Variable, and we give it a name, variable name, and this is name is the name of the location of this value in the memory. So remember, memory has places where we stored value. So here is the variable name, is the name of this location where this value is stored. Here is an example like var1 equal value whatever you want. Now we declare the variable, we give it a value. What if during the application running I would like to reassign this variable another value depend on some kind of calculation? That we call it reassignment. From here, variable name equal new value. Also var1 equal new value. And here is full example how looks like in reality. Var number 4, I give it value of 4. Boolean logical is online to check if the user online or offline, true or false. Variable name Muhammad because this is here now as string. So that's how the variables declaration look like. Here is declare, here is assignment, here is reassigning the value to a variable. Takes us to operations which we can do on variables. For all the variables, And for the data type, because data type is different, means that operation also is going to be different. True or false operation will be totally different than the numeric operation. Numeric operation will be different than the object or the character. We will speak about operation, and you will learn about the operation when you learn the specific programming language which you start learning it. For example, for the numbers, we have the mathematical operation, division, additional, subtraction, equal, module, or multiplication. That's for the mathematical or for the numbers, for example. We have also the comparison, where you compare two different variables. At the end, you got a result, true or false. For example, you check if variable 1 is less than variable 2. If it's true, you will have result as true. Variable 1 is greater than variable 2. Also, if it's true, you will have true. And variable 1 equal variable 2, or the opposite, variable 1 not equal variable 2. This sign, this is not. It is the reversing operator. We're getting into the logical now. The assignment here, for example, will give us true or false. Now I use true or false into another logical check, like for example and, which means variable 1 and variable 2. If both are true, so the result will be true. Variable 1 or variable 2, if one of them are true or one of them is false. And not and reversing the result. If the result of this boolean is true, using this not before the variable result, it will reverse it. So if this is true, it will be as a whole false. If this is false, it will be as a whole true. So this sign is used to reverse the result. Remember that. This is a reversing sign of the result. Let's now get into object. What is object in programming? Object is anything has attribute and behavior. Usually we build object from what we call class. We will speak about classes sooner. For example, you have a person. Person is like object, and this person has a name. So attribute name, attribute height, attribute weight, and this person has a behavior. He can do some actions like move, like talk, like think, for example. We have another object like a car, for example. The car has a brand attribute, color attribute, and type attribute. And also it can do some action, some behavior like moving, signaling, lighting, etc. Next one, it will be class. What is class and why class is so important? Class is only empty template to be filled. You have class is something empty. Let's imagine something like this. You get into some office, and in this office, the office guy will give you application. It's totally empty application, and you are going to fill it by your own data. The same exact application will be empty, will be given to another person, will be filled by this person data. So the same exact application, it gets used by two different persons for two different purposes and by two different data. That's what is class. Class is only empty template. There is nothing in it. It's holding data in the future, and we call it instance or we call it object. That's why class is a template, and from this template we are going to make objects, as we will see soon. For example, let's say we have a person class, and from this person I can make businessman object, I can make a teacher object, I can make a doctor object as well. Now we get more into class. How the class looks like in programming language. Class looks like follow. This is one of the programming language. Class, name of the class, variables. The class has variables, and each variable, it holds a specific data, depends on the data type. For example, here is var id, here is string data type, here is integer data type, which mean numbers. Constructor, it's a special method or function. It's made for the class to be built or to instantiate what we call it object. We have empty class, which means that we have nothing at all. It's just empty, it's still empty, and we can fill it later by using set username or set age or set ID. We have ready-made class. We will just give it our values and it will instantiate this class as object immediately. And we have methods here or functions, the same methods here or functions. How can I use this empty template right now? Simple enough, by this way. I am saying that person is a data type or class person. I give it a name and I will say new person. This is empty, so person.set username. Now I will instantiate this object using this name, username. Second one, I can do another instance or another object from this class by using person2, and I will give it all the data immediately. That's how the class looks like. Then we have a special variable, it's called collection. Collection is when you have a collection of data and you would like to assign all of them to one variable only, because this collection of data, they have something in common. For example, all of them are numbers, and instead of doing variable 1 equal 1, variable 2 equal 2, variable 3 equal 3, there is no need for this hassle. We have a collection, we use array, and in this collection we store all the data as a sequence one after another, and we assign it a special variable. We will speak about collection later when we speak about data structure. Variables are used also to make a decision as a decision maker. So decision maker is when you choose and when you decide right or wrong, left or right or whatever. The first function or the first option to make a decision maker is what we call it F. If something is true, so do some action or ignore this place. For example, let's say that we have variable number equal 4, and then if number is equal 4, do actions inside this yellow curly braces. If this result of this operation isn't true, ignore what is inside this body. That we call it body of this function. We will speak about functions also soon. So this is the first decision maker. It is F. If it's true, do something. If it's false, do nothing. There is no need even to look inside this body. Next one is if else. When you have a default behavior, for example, let's say variable number is 40, and now if number equal 4, do something, but if it is not equal 4, else do something else, which is inside this block. So simply the computer application will check if this is true, do this, but if it's false, by default do this block of code. We're getting into if you have a multiple things to check, a multiple results it could be. We use if, else, if, like if, else as default. For example, let's say again 40, if number equal 4, do something, else if number equal 400, do something. If it's not even true any one of them, so do the default behavior down there. So simply check this line. If it's true, do the actions here and ignore the rest. Else if this one is false, check this one. If it's true, do whatever here and ignore the else. But if it's false, so ignore it and do whatever inside this block of code else. Because writing such code is a bit not tidy, we have switch operator. Switch is the same exact idea of else if, but we use what we call it case. For example, variable number equal 40, I create the switch, I give it the number 40, and inside this yellow curly braces I have cases. Case is exactly like if. For example, case 4 means that if this number equal 4, do some action, then break, then do nothing. Another case it could be if this number equal 1. Another case it could be. So you can have multiple cases replacing if, else if like this. And then at the end you have the default value. If there is no case matched this number, you can do something by default. That's the switch. Now we will get into data structure. What is data structure? Introduction to data structure and simplify it. Data structure is a collection of elements, variables, and there is a relation among them and the operations applied on this data type. So let's divide this into smaller parts, starting by data. Data is variables. You have a lot of variables and you store them into this data structure because you have a structure. And then what is structure? Structure is the relationship between the elements and how you store them. Depends on the data type. We will get a little bit more when we are explaining more about data structure now. Operations. This operation depends on the data structure, depends on the data type and the structure of this data into the collection. Collection is just, even from the name, it's collection. Collecting a numbers of variables, they have something in common or they have a similar data type. That's a collection in simple way. Similar to this one, like dog and cat, they are both animals. So we can store them here and we call this animals collection. So let's get into the types of data structure. We have ordered data structure. When you insert some value, it will be inserted and somehow get sorted and ordered 0, 1, 2, 3, 4 like this. We have unordered. It doesn't make difference the order of the value inside this data structure. We have unique value data structure where you store only unique value in this data structure. We have also non-unique value where you can duplicate the values. It doesn't make any difference for this data structures. And we have data structure allows what we call it null value. It's null, there is nothing. Then we will get into implementation of data structure. What is the data structure we are using in programming? We use first one, and the most famous is arrays and lists. Arrays and lists, they have things in common, like they are storing the data one after another. When you insert something new, you insert it at the end. As you can see, there are blocks here, and inside this, it's like a table. If you look, it looks like a table, and each block of this one is storing one specific value, and if you have a new value, it will get into the end over here. That's arrays and that's lists. You deal with this arrays and lists by what we call it index. Index is the number of this block, not the value. For example, this block 0, this block number 1, this block number 2, that we call it index in data structure. The value is different. We will speak about this when we get into how we can find data from the data structure. Next one, it will be map. Map is another data structure where you store the value like key, value, pair. You have key and you have value. It looks like, for example, your apartment. You have key for your apartment, and you are the only person with that key will be able to get into this apartment, which containing all of the value you have. This data structure is used also to store this value similar to arrays, but you don't have index here. You have key. You use this key to retrieve value or to save value or to operate over this data structure. Queue is simple. The first data get in is the first data should get out. That's the purpose of the queue. It's you put data in a row. Something similar that you go to any governmental organization or any place, and where there is a line of people one after another waiting in a queue. The first one will get the window, will finish his job, and then will go out, so the second one will get in. So the similar of data structure, it's called queue. We have stacks. Stacks is the opposite of queue, which means that last value gets in, it is the first value will go out. Stacks is used generally in programming languages to organize the operating of the function and how the application starts. When you start the application, this is we call it entry point. So the entry point will be value 1, will get down here. Then from the entry point, you will call another value, will get over this value, and you will call another one, you will get in the top. So when the first one is finished, it will be done, then done. After that, the second one is done, then the first one is done, the application will get out. Heap, binary tree, they have things in similars. They are like a tree where you store the values into what we call it nodes. Similar to the tree, there is specific functionality to balance between them and how to use binary, how to use heap, and how to use them. That should be later when we speak in details of what is data structure. Now, what is operations we use in data structure? First one is iterating. When you loop into the data structure to get some specific value or to display value or to manipulate this value. Inserting, when you add a new value into this data structure. Removing, when you remove something from data structure. Find, when you have something specific you want to find in this data structure. Update, when you would like to update one of the values or to replace it with a new one. Sorting, when you would like to sort this data structure. We will start with the first operation, which it is iterating. How can you iterate over data structure? Iterating meaning that linear traversing of the collection from the beginning to the end linearly, which means that you start from 0 to the end of this data structure one after another. That we call it iterate or loop. And the operation is depends on the data type. Iterating operation, what kind of functionality used in programming language, and it will be common and mutual in all programming languages. The difference is just maybe how you write the command itself, but the idea is exactly the same. First one we call it while loop. Let's example that we have this collection storing the numbers over here, and I would like to loop over this collection to do some kind of operation over this collection. I create condition I give it, for example, 0, and then while this condition is equal 5, if it's not equal 5, I do something over this collection of data structure, and then I will update the condition by 1. Plus is mean update this condition by 1. Then the while loop will get into again to check, is condition equal 5? No, it's not equal 5 yet. So do some action, update the condition, and then gets in again. Is the condition equal 5? No, not yet. So continue until this condition will be true, then stop the while loop. You should have condition to stop the while loop. If you don't stop the loop, it will be infinite looping into your application, and that could stop your application from working. So iterating over collection, you should have some mechanism to stop the iterating when you got the specific results you are looking for. So the first one is while loop. Now we're getting into do while loop. Do while loop is similar to while loop, but the difference is we have to do something before it checking the condition. So I will do some action, and then I will update the condition. After that, I will check the condition if it's true or false, which means that before the termination of this do while loop, at least I can have one action done regardless of the condition. That's why it's called do first. So it will do action and then it check the condition. That's sometimes used when you have login check or when you have some specific functionality where you need to do action regardless of the condition and at least once. You can define this when you start working on your application. One of the most famous iterating is for loop. For loop is exactly similar to while loop, but the only difference that you have everything on one line. Here is the condition, and here is the checking of the condition if less than 5, and here is the condition upgrading, and here you do some action over this collection. It's just simplifying version of while loop by adding everything on one line. But also this operation will stop once this condition being true. Then we have for each. For each, it is similar to for loop, but the only difference that you don't have a condition here. The condition is the length of this collection. So the for each will start working automatically until it will reach this collection's end, and it will be terminating. Now we get into another operation. Now we spoke about the iterating operation. We will speak now about inserting. Inserting is depends on the data structure. How you insert value into the data structure, you check. Some we can like map, you insert it by key, arrays and lists you insert by index. Removing is also the same, depends on the data structure, by key or by value. Finding exactly the same, depends on data structure. You can find by ID, by key or by value. Also we have update or to replace, you do the same, depends on the data structure, ID, key or value. And we have sorting, that you can sort the values into this array up or down. This data structure is using algorithms for search, for find, for whatever you are doing on this data structure. For that reason, we have what we call it algorithmic efficiency. Algorithmic efficiency is where you test the efficiency of using this kind of finding or search or sorting over one data structure. It's called big O notation. The number of computational resources used by the algorithm which you are using for searching or for storing or for whatever operation you do over the data structure. Time complexity, like the time it takes to finish a specific job on a specific data structure. Space complexity, like the size of the data structure. We finish an overview of data structure. Now we get into function and method. We spoke all the time about function, method. What it is, what is functions and what is method. Function simply or method is a block of code. You have block of code closed into a curly braces, encapsulated on itself, which means that the functionality inside this block of code shouldn't be exposed to outside of this block, and it will do some specific task depends on your need. You can define function, custom function yourself, and you do whatever you want. And function is good for reusability. When you have function, you can get the result of this function, assign it to a variable, or you can call this function for another place in your application. As we saw that we have built-in function like if else, like for loop, while loop, all this built-in function. And then we have custom function where you do the function your own yourself to define some kind of code. What is the anatomy of the function? How the function look like? How you can write a function? Depends on the language, you will learn how to write a function or method. But simply enough, any function or method, it has a parameter. Parameter is the inputs where you give it to the function to process. And then you have the return value after processing the code or the parameters inside this block of code. If there is nothing to return, we call it void function or void method. If there is something to return, we will return the data type depends on this computation inside this block of code. How the function look like? Here you can find the return type of the function if there is one, function name, between these braces we have the parameter list, and then the body of the function. That's how the function looks like in any programming language, but how you write this, it depends on the language you will learn. Second one is the keywords. What is keywords? For all the programming language, there is a list of preserved words. There are some specific words which unique and used only by this language. You can't use them as a user. You can't, for example, declare variable name and you call it variable because variable, for example, is a reserved keyword. You can't make function, for example, or whatever, int. So reserved keyword used to map certain actions of the language you will learn. Each language has its own keywords. We get into exception handling. Exception handling is the error during the application running. Your application is running and something unexpected happened, and you should recover from this exception or from this error. That's why you call it exception handling. You handle the recovery. Also, each language has its own way of recovery from the exception. Languages using what we call it try catch block. Try, then you write the code that you expect it could throw some error, and after that you make another catch block down there and you write the expectation of what to do if this error occurred during the application running. Other application you can use if else. If something went wrong, else do this default action. We get into file. Is a collection of variable and functions, because file is where you will write your code. Do you remember when I showed you the person class? Person class was written inside the file. That file we use, and we use its extension to determine the programming language which you are using. Each programming language has its own extension. For example, .java it's for Java, .gs for JavaScript, .py for Python, etc., etc. So each programming language has its own file structure and has its own file extension, and that's used later on in different places in your application. Most of these files doing specific functionality, we store them into what we call it package. Package is a collection of related files or classes. For example, you have some files. All these files are doing mathematical operation. You can put them into a package and you call the package mathematical operation. You have other files, and this file is working with front end, like with images. You put them into a package and you call this package images. Package is just folder where you store your files. In your computer you have folder for songs, folder for movies, folder for words, stuff like this. That's package. And the files doing similar functionality as we said, and used for importing in a new file. For example, some programming language use package, another programming language call it module, and we use this package or module to take the files from this package and using them into another package. Your application will contain of several different packages. Sometimes you need to use a specific file from another package. In this case, you will make like import this package or import this file from this package to use its functionality inside your own class or your own application. When you finish writing your application, now you need to run your application. You need to deploy it. You need to do something, because usually you need to have the final version of the project. You finished, you run on your computer, is working fine, there is no problem at all. Now it's time to transport it to other people to use your application. That's why you have the final version of your application. You put them into package, you collect everything inside this package, and then you export it to other people for executing and ready to use. Each programming language has its own way to export this executable file or the project package to be used in another places on internet or home or whatever where you are using it. We have in programming design patterns. Design patterns is in general reusable solution to a problem. We always face a specific problem. Sometimes this problem got repeated several and hundreds of times. Programmers facing this problem in different programming language. For that reason, the programmers community decided to have a specific set of codes, reusable solution. In case if you would like to write code and you have similar issue, you will use the same solution which exists, like a best practice to solve any common problems you can face in the future. That's why we call it design pattern. All the programming languages having specific design patterns. It's only different is that how you write this design pattern depends on the programming language. Also, there is some common functionality. You will find them in all the programming language. Something like dealing with files, dealing with directories. If you have how you can communicate with computer to import file from the computer itself, how you can handle Word file, media file, images file, music file, or whatever. Each programming language will have its own way to handle working with this computer. We have also internet communication, how you can work with internet. HTTP call, do you need something online, you need to do something offline, all this stuff you will have it in the programming language of your choice. SQL, which means database handling, how you can deal with database, how you will work with the database. Programming language will have also its own functionality to do that action. Also, we have something related to security, how to secure your application, how to do some password manipulation or any other stuff related to security. Each programming language will have also its own way to do that. The same with artificial intelligence, machine learning, and etc. We reach the end of our presentation. I hope that the presentation was beneficial for you. I hope by this presentation now you have a clear roadmap of how can you learn programming languages, where to start, where you will end, which programming language you choose is totally up to you. But now use this roadmap when you start learning programming language. If you really enjoyed this video and if you really think that this video is valuable and is good for other people, so share it, enjoy it, and I wish you all the best in learning programming, and I welcome you on board. Thank you so much for your time and for listening to my videos. Peace be upon you.